Hello friends, welcome to Shiksharthi. In this video, we will learn how to compare fractions. So let's start. So here you would see, giving reference to my earlier videos in which we have already talked about fractions, types of fractions. Now in this video, we will be using whatever we have done, plus we'll be discussing some new things. So we will first talk about the basic methods of comparing two or more fractions, and at this time I am taking only proper fractions. Why? In few minutes we'll share the reason why are we taking only proper fractions. Then once we have done that, discuss the basics, then we'll be moving on with various concepts. Maybe two or more fractions is what we are going to discuss, and then we'll summarize how to use various methods. Okay. So the basic method of comparing any two fractions would be take the LCM of the denominators and then compare their numerators, right? So in this case, you will see that I have taken one fraction as 2 by 3 and the other fraction that I have taken here is 5 by 7. Now when I compare these two fractions, and deliberately I have taken easy examples because once I am able to understand the easy examples, then it becomes easier for me to apply those methods with slightly difficult questions. Okay. So if I take the LCM of these two, the LCM comes out to be a 3 into 7, which is 21. So in that case, what do? We just, this is just like saying 2 into 7. So the numerator here is what? Once the denominators are equal, we just compare their numerators. And when we compare their numerators, in this case, I'm getting the numerator value as 14. And in this case, I'm getting the numerator value as 15. So what will we say? We will say that this fraction is smaller or lesser than this fraction. Right? I hope this has been understood. Second is a method wherein we can cross multiply. But keep this thing in mind. Here we are talking about the basic methods. Cross multiplication method may be easier or may be efficient only when there are exactly two fractions. And why do I call this as a calculation method? Is because I am asking you to cross multiply. Now when I am asking you to cross multiply, in that case, this number, here when I am asking you to cross multiply, it is nothing but the extension of this method only. But now in this case, the numerator becomes what? 23 into 61. And in this case, the numerator comes out to be a 47 into 37. And I have deliberately taken this example because now this would take you some time to calculate. Right? Maybe we can work out better methods. I'm not concerned with the answer for the time being. If you can just work out the answer, because you know in my earlier videos, we have already talked about how to multiply a 2-digit number with another 2-digit number. Right? Okay. So the third method here is, which is nothing but the extension of these two methods only, which says either equalize the numerators of the given fraction or equalize the denominators of the given fractions. Didn't understand? Let us take an example. So here I have taken two examples. So first I am going to discuss only this example wherein the fractions that I have taken are 12 by 13 and 36 by 37. Right? So now what am I suggesting? Here what I have done is I have taken an equivalent fraction to this. What is an equivalent fraction? Wherein I multiply the numerator and denominator by the same number. And here we are talking about a non-zero number to be multiplied with. So in this case, I have multiplied the numerator and the denominator by a 3. In that case, this becomes 36 by 39. And the next fraction here was 36 upon 37. Now, once their numerators are the same, can I say the denominator of a fraction is not directly proportional to a fraction? Is not directly proportional. Meaning thereby, once I am able to establish the fact that the numerators are equal, the fraction having a greater denominator will be lesser than a fraction which is having a smaller denominator. Right? So in this case, once their numerators have been equalized, which fraction has a greater denominator? This fraction. So this fraction originally becomes the smaller one. I hope you understood. Now using the same thing, I can go back here. Now once I go back here, I am able to recollect that can I write an equivalent fraction here, equivalent fraction. Yes, and I can write an equivalent fraction like 23 upon 37 can be written as 46 upon 74. Now, in a certain sense, their numerators are almost equal, almost. The difference is very less. So can I say, I mean, using the same method that I have used here, can I say that the numerators are equal here? The fraction having a smaller denominator will be greater than the fraction which is having a larger denominator. So answer. So these are the three methods that we have used, which are the basic methods which ideally should be used to compare two fractions, ideally. Or you can extend them also dependent on the ease of operations. One more example that I have taken here is, so one fraction that I have taken here is the same fraction which is 12 by 13, and the other fraction that I have taken here is 77 upon 78. Now immediately, I mean, who would tell me that I am supposed to equalize the numerator or the denominator? Your presence of mind, your practice will suggest that here 78 is a multiple of 13. Now the moment you are able to establish the fact, 78 is a multiple of 13, so we write an equivalent fraction. So 12 by 13 can be written as 72 by 78. Yes. And this fraction is already as 77 upon 78. Now you have the denominators equal. So you can simply compare their numerators, and the fraction having a greater numerator will be a greater fraction. So talking about the third method, and if I have to use ratio proportion, because ratio proportion and fractions, they go hand in hand. So if I were to use the law of proportions, I can say that the numerator of a fraction is directly proportional to a fraction, and the denominator of a fraction is inversely proportional to a fraction. Which is why we said that in case if the denominators are equal, the fraction having a greater numerator will be originally greater than the other fraction. And in case if the numerators are the same, in that case the fraction having a larger denominator will be the smaller between the two. Why? Because the denominator of a fraction is inversely proportional to a fraction. Now taking this discussion forward. So now here you would see that we had taken relatively easier examples, but the examples that we are going to take now would be slightly of a higher level as compared to the examples that we had already taken. Okay, so now if I take these two, again we are taking two fractions only, but now we are going to discuss something else. So let us say these are the two fractions that we have taken, and this is a sign of relationship between them. Now when I say this is a sign of relationship, means what? Maybe this is greater than this, maybe this is lesser than this, maybe this is equal to this. In life you always talk about equality or inequality. So when I am comparing two or more things, in that case we can only talk about three things. One is either I talk about the greatest, least, or maybe they are equal to each other. So now in this case, what am I suggesting? I am asking you to take the reciprocal of these fractions. Reciprocal is now the numerator becomes the denominator and the denominator becomes the numerator. So once you have done this, this becomes an improper fraction. Right? Now in an improper fraction, now we are talking about positive improper fractions. So in the positive improper fractions, if I am able to segregate, write this in terms of a mixed fraction, which we have already learnt in the earlier videos. So once we are able to establish this, can I say that for two improper fractions, higher the quotient? If you recall, we had talked about an improper fraction can be written in terms of quotient remainder upon the divisor. Correct? So now in this case the quotient is 1, and in this case the quotient is 2, and then the remainder divided by the divisor. So higher the divisor in a positive improper fraction, greater would be the fraction. So here if I talk about between these two fractions, which one is greater? The fraction having the higher quotient in it, or the integer content in it. But originally the sign of relationship was just the inverse. So can I say this fraction becomes greater than this? Of course. Yeah, the more you practice, maybe there will be a point in time, as I said, if you practice every day, if you practice calculations every day, because fractions, again when it comes to comparison, it is all about calculations only. So the faster you would do, but right from the day one, you are supposed to focus only on accuracy. Okay, the next concept here, So maybe we are going to use the same concept, but now here fifth point comes as a different point wherein we are taking three fractions and we are doing the same. So we imagined that this is a sign of relationship between the three fractions, and then what did we do? We inverted them. We took the reciprocal of them, and then we segregated what? We segregated the question part and the remainder part, I mean the integer part. Incidentally, this becomes a difficult question. Why? Because the integer part in these mixed fractions that you are getting are the same. So this question looks to be easy wherein it is not. But now what I am supposed to do is, once I get the same integer part, I will focus only on the fractional part of the mixed fraction. And then a method that we had learnt earlier, we will be able to apply the same. Which method? Now you will come across these are three fractions. You will focus only on these three fractions now, in which the numerator is the same. So the fraction having the smallest denominator. So which is the fraction having the smallest denominator? This, right? This should be the largest fraction among them. But here we have the sign of, I mean this is a reciprocal sign. So if this is the largest fraction and this is the smallest fraction here, originally this becomes the largest and this becomes the smallest. So let's say L1 is the largest, this is the second largest, and this is the third largest. For the sake of reference, I am writing it down. I hope you understood. Last but not the least for today. Now you will see again I am taking three fractions only, but now here I am taking relatively a bigger fraction. I am taking a 3-digit denominator and a 3-digit numerator. So we'll be using whatever we had discussed earlier, and now we will try and do it faster because we have already practiced few methods, and once I have already focused on accuracy, it is then we talk about accuracy and speed both. So in this case, can I write these fractions like this? What I have done here is I have divided the numerator and denominator both by 112. Same here, I have divided the numerator and denominator by 253 and so on. And then I have done the same. I have separated the integer part and the non-integer part. This ... means the non-integer part. I hope you are aware of the fact we had discussed integers are numbers which are written without a decimal point, and non-integers are those numbers which are written with a decimal point. Whether they are positive or negative, that doesn't make any difference to the definition. Okay, so can I write, this is just like you had to imagine, without writing you had to imagine that this is just like saying 1 divided by a number which is slightly greater than 1. This is just like saying this is 1 divided by a number which is slightly greater than 2, and this is just like saying 1 divided by a number which is slightly greater than 3, and then applying the rule that we had discussed here. Same numerators, so the fraction having the largest denominator will be the smallest fraction. So let's say L3, this is L1 and this is L2. The last thing for this session, so when I am comparing two fractions, I can compare one positive fraction with another positive fraction, which we have already discussed with the help of 6 concepts. We can compare a positive fraction with a negative fraction, which I have not discussed here. Why? Because a positive number or a fraction is always greater than the negative, which is why it has not been discussed. The last case which we have not discussed here, which I would give you as a homework, is how to compare between two negative fractions. Whether they are proper, improper doesn't make any difference to the interpretation, as long as you know how to compare them. So for this, I have just taken first example that I had taken here. Now we know that when I am comparing two positive proper fractions, we know that 2 by 3 is greater than 5 by 7. But the same thing, if somebody gives me minus 2 by 3 and minus 5 by 7, what am I supposed to do? Compare 2 by 3 and 5 by 7. Remove their signs. Sign, S-I-G-N. So remove their signs. So once you are able to establish this, but originally you are comparing two negative fractions, so the inequality sign changes. Meaning thereby, if I am saying that 2 by 3 is greater, 2 by 3 is lesser than 5 by 7, in that case minus of both the fractions, minus 2 by 3 becomes greater than minus 5 by 7. On this note, I will leave here thinking that you will practice whatever we have discussed with the same examples, and once you are able to say that yes, this practice is enough, then you can take it to a next level. Next level is you take more number of questions And more number of questions could be what? You introduce 4 fractions and then compare among 4 fractions. You take improper fractions, which indirectly we have already taken. How to compare improper fractions. Right? If you feel that something knowledgeable has been discussed today, please do not forget to like, share and subscribe to our channel. If you have already done so, please turn on the bell icon so that you start receiving updates. Thank you so much. Until next time we meet, goodbye.